Jai Hind dear students, I am Dr. Preeti Mittal and today we are going to revise the NCERT book questions of the chapter Human Eye and the Colorful World. We are not going to discuss each and every question. We are just going to discuss only the questions which are quite a tricky one. So, starting with question number 5, you can all sit with your NCERT book so that you can have a look at the questions. Question number 5, a person needs the lens of power of the lens is given minus 5.5 diopter for correcting his distant vision. The person is having a problem looking at the distant objects, and for correction of that, he requires a lens having a power minus 5.5. Minus sign here shows that a lens is a concave lens, and that is required for the correction of distant vision problems. Okay. So minus sign, why it's minus sign is showing that it's a concave lens? Because you all know that concave, whether it's lens or mirror, the focal length is negative. And if the focal length is negative, then the power is also negative. Now, for correcting his near vision, means a person is having a problem in seeing the nearby objects also. Means the person is having both the problems, distant vision as well as near vision. Means the person is suffering from presbyopia. The condition is known as presbyopia. For correcting his near vision, he requires a lens of power plus 1.5 diopter. What is the focal length for the lens required for distant vision and for near vision? It's very simple question. So you all know that focal length is 1 upon P. So that will be minus of 1 upon 5.5. That is in meters. This is your answer in meters. But we'll find out the final answer. To find it out, we'll just convert it into centimeter. That will make our calculations to be easier. To convert meter into centimeter, we just multiply it with 100. So it becomes minus 100 upon 5.5. But I would like to remove the decimal as well. And so by removing the decimal, I'll just get a 0 in the numerator. Fine. If we divide that, we'll get minus 18.1 centimeter. Okay, just divide that and you'll get the answer as minus 18.1 centimeter. That will be the answer. That will be the focal length of the first lens. Okay. Now, for near vision, the focal length will be, that is again 1 upon power, that is 1 upon 1.5. Again, this is the answer in meters. We'll try to convert into centimeter by multiplying with 100. So, it will be 100 upon 1.5. Again, I would like to remove the decimal by just placing one more 0 here. Okay. And if I solve it out, I'll be getting 6.6666 could be written as 66.67 centimeter. Okay. So that's all. That is the focal length of the second lens, and the person is suffering from the condition that is known as presbyopia, because of which the person is not able to see the nearby object as well as distant objects. You can take a screenshot of the question if you want. Now, coming to the next question, number 6. The far point of a myopic eye is 680 centimeter in front of eye. But before that, tell me, what is the normal person's far point? What is the maximum distance up to which a normal person can see? That distance is taken as infinity. But for that particular person, the far point is given to be 80 centimeter. Now, what is the nature and the power of the lens required to correct the problem? To find out the power of the lens required, we need to find out the focal length first. Okay, I'll let you know a trick also, and we'll do the solution in a proper way as well. So, in this condition, if just imagine this is a student. If the student is sitting on the last bench, then the person is not able to see that. Means if the board is at infinity, means the object is at infinity, object is always placed in front of eye, so that distance should be taken as negative. Object distance is always negative only. Then the person is not able to see that. But if the person is made to sit on the first bench, suppose that distance from the board is 80 centimeter, then the person is able to see that board. But it's not possible for the teacher to make that student sit on the first bench every day. So the student should be provided with some spectacles, so that spectacles are provided in such a way that the image of whatever is written on the board comes to a distance of 80 centimeter for that person. So the spectacles provided to that person is in such a way that the image of a distant object is formed at a distance of 80 centimeter in front of the eyes. Then we can easily calculate the focal length. In this numerical, you just need to work out what is the u and what is the v. So now what will be the focal length? 1 upon f is equals to 1 upon v minus 1 upon u by using the length formula. With every question you should write by using length formula and then only write the formula. That is equal to by length formula. Okay, so placing the values minus 80 minus of 1 upon infinity. 1 upon infinity is 0. Anything divided by infinity is 0 only. So that will be minus 1 upon 80. Minus will become plus 0. Whatever it is, if we add 0 or subtract 0, that doesn't make any difference. So focal length is equals to minus 80 centimeter. That will be the focal length. Okay. Now, I will be telling you a trick also. Whatever value is given in the question, that will be the answer for your calculation of the focal length also. If the near point of the person was 60 centimeter, then the focal length would have been minus 60. Okay, but just remember that it will be a minus sign associated because the person is having a problem in seeing the distant objects. Means the person is having myopia or short sightedness. पास की चीजें देख पाता है, दूर का नहीं देख पाता. So the lens prescribed to the person will be a concave lens, and so the focal length will be negative. Now you are asked to calculate the power. So power, you all know that's 1 upon focal length in meters, or you can write 100 upon focal length in centimeter. Okay. So if the answer is given in centimeter, we will use the second formula. So that is 100 upon f. Value of f is given minus 80. If I solve it out, then I'll be getting minus 1.25 diopter. Okay, so that will be the power of the lens required. Negative sign is correct because the person will be requiring a concave lens. I'll just shift aside so that you can take a screenshot if you want. Now, question number 7. Question number 7. Make a diagram to show how hypermetropy is corrected by using a convex lens. You can show that. We have already made the diagram in the previous video. You can go through that. The near point of a hypermetropic eye is 1 meter. Now, in the question it's given, what is the near point of a normal eye? That you should know. It could be given in the question, but probably it won't be given in the question. The near point for a normal person is 25 centimeters. Means if the object is placed at 25 centimeters, the person will be able to see that easily. But in case of a hypermetropic person, the person has to keep it away from it. In this question, the person has to keep the book at 1 meter distance. Okay, it's too much now. The person has to see like this. So now, is it okay for a student to look like this every time into the copy or book? No. In that case, we can provide the spectacles to a person in such a way that the image of the object is formed at a distance of 1 meter. Means the image will be formed at a distance of 1 meter, but the object will be placed at a distance of near point of the normal person only. Okay. So the near point is 25 centimeter, and so we are going to place the object at the near point only, like normally every person do. but the image will be formed at a distance of 1 meter, that is equal to 100 centimeter. So the person is able to see that clearly. Now find out the focal length by using lens formula. We know that 1 upon f is equals to 1 upon v minus 1 upon u. So placing the values, 1 upon f is equals to 1 upon minus 100 minus 1 upon minus of 1 upon 25. Why minus? Because this is the minus sign of the formula and this is the minus sign of the u, value of u. So it will come as minus of 1 upon 100 plus 1 upon 25, minus minus becomes positive. So solving it out, 1 upon f is equals to 100 will be the LCM. In table of 100, 100 will come 1 time. So it's minus 1 plus 3 times 25 times 4 is 100. So it will be plus 4. So it will give you 3 upon 100. So the focal length will be 100 upon 3. And let it be like this only, because we are not concerned with the focal length. We are asked to find out the power of the lens. This is the answer in centimeters. Okay, this is the answer in centimeter because we have taken all the values in centimeter. Now we know that power of the lens is 1 upon focal length, or we can write it as 100 upon focal length in centimeters. So let's put the value 100 upon, what was the value of focal length? 100 upon 3. 100 and 100 gets cancelled out. So the power of the lens will be plus 3 diopters. The power of the lens that is required for correcting this disorder will be plus 3 diopters. Positive sign shows that we need a convex lens to correct this defect, because this defect is hypermetropia. Okay, so you can take a screenshot. I hope you were able to understand the question. And this question in your NCERT book, they have given the value of near point. But everyone should remember that near point of a normal person is 25 centimeters. That can come as a 1 marks question as well. Now, the last question that I want to discuss with you, that is question number 9. What happens to the image distance in the eye when we increase the distance of an object from the eye? So, if I am placing this object here, then where the image will be formed in my eyes? That will be formed on the retina. But if I observe something that is very far from my eyes, where the image will be formed in my eyes? Still that will be formed on the retina only. So the distance of the image will not be changing with the distance of the object. I can place the object here, or I can place the object at a great distance from my eyes. Still the image will be formed on the retina only, and the distance between the eye lens in my eyes and the retina is not going to change. So that will be remaining the same. Do you remember that distance? What is the approximate diameter of the eyeball? That is 2.3 centimeter. That is approximate diameter of the eyeball. Okay, so that image distance is not going to change because the shape of our eyeball is not going to change according to the distance of the object. Then how the distance of the image object is not changing? Because we are changing the focal length of the eye lens. Okay, so when the distance of the object is changing, we are changing the focal length, and that is why the image distance will remain the same. It will not be changing with changing distance of the object. Okay, so that's all for this video. I hope you are preparing for your exams very well. Keep studying and score very well for your exams. Good luck from my sides and blessing from me. That's all for today. Good day everyone.